Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, we meet again in the new video. So, in this video, I would like to discuss past year's exam paper. This is CES 521 Indeterminate Structures, June 2019. Okay, I have actually picked one question. This is actually Truss analysis using stiffness matrix method, question number 3. So let's look at the question now. Okay, so a pin jointed truss ABCD as shown in the figure Q3 is pin supported at A and C while support B is supported by roller. Okay, this is the truss. Point A, B, D are subjected to horizontal and vertical point loads of 25 kilonewton, 25 kilonewton, and 30 kilonewton respectively. Okay, AE is 3.5 exponent 5 kilonewton. Remember that AE is in unit kilonewton. Using stiffness method, number 1, draw and label the diagrams for unconstrained degree of freedom and constrained degree of freedom. Okay, number 2, establish the force displacement equation corresponding to the constrained and unconstrained. Unconstrained and constrained, the same thing. If member BD is fabricated 5 mm longer. Okay, so this in this question we need to consider effect. It means we need to calculate the equivalent element nodal forces which is occur in member BD. Okay, and after that analyze the internal force in member BD only. So this question C is member force. Okay, question C is member force, question 1. Okay, so for truss analysis or for any type of structure, we have actually learned how to analyze truss, beam as well as frame. So these three type of structure, when we want to analyze using stiffness method, we need to follow the step. We need to follow the procedure. Okay, because in stiffness method, what we need to understand is we will determine the first output is unknown displacement. The first output from stiffness that we can get from stiffness equation or force displacement equation is actually the unknown displacement. Once the unknown displacement have been determined, then only we can determine either reaction at the support, or we can also use the displacement value that we have determined to calculate member forces. Means that reaction, to calculate reaction, we need displacement, unknown displacement. To calculate member forces, also we need displacement. Okay, so as I always mentioned previously several times in structural analysis, actually we only deals with three types of output. Okay, the first output that we get from analysis is displacement, and then internal the first thing, if we follow the procedure, the basic procedure, it is actually come from it is actually a reaction, and then internal forces, and after that is displacement. But using stiffness matrix method, okay, what we can get from this method is the first thing is the displacement. The second one is either reaction at the support, or we can also get member force. Okay, depending on the question. Okay, and the basic equation and the basic equation we call it as force displacement equation Q. Q is equal to KD. This is the basic equation. Q is equal to KD, but this is for basic equation, especially for truss. But whenever truss has the effect which come from either temperature changes or fabrication error, so we have to include Q naught. So temperature changes and fabrication error, we must include as Q naught in truss. Okay, we must include as Q naught in truss. So it will occur whenever the temperature changes or fabrication error, okay, is given in the question like this, where we have to consider fabrication error in member BD. Okay, fabrication error in member BD. It is fabricated 5 mm longer, means that this is delta L. This is delta L, and in fabrication error we have longer, we have shorter. So we assume that longer is positive, shorter is negative. Okay, same goes to temperature changes. We have temperature increase, we have temperature decrease. So for temperature and we also have hot and cold. So hot we assume positive, cold we assume negative. So of course increase is positive, decrease is negative. Okay, so we have to include this delta L whenever we want to solve for the displacement. So delta L in this case it is longer than, so this is equal to positive 0.0005, because it is 5 mm, so this is in meter. Okay, so always remember, so by looking, okay, we move to the structure first. Okay, the truss. Okay, we move to the truss. So we double check number of degree of freedom, number of nodes. So there are okay, how many nodes? 1, 2, 3, 4. So there are 4 nodes. So there are 4 nodes, which is equivalent to 8 degree of freedom. 4 nodes, which is equivalent to 8 degree of freedom. Okay, so A and C are pin support. So normally, as I always mention, the easiest way to identify or to put the degree of freedom, okay, the level of degree of freedom is we identify from number of unknown reaction, because number of unknown reaction is actually occur in constraint system, means that constraint is representing support. So at A we have 2. At C also we have 2. And we have roller at B. And by looking at the position, we have the degree of freedom, okay, in this direction. Okay, in this direction. Okay, so again, this direction. Okay, so there are 5. There are 5 unknown reaction. 5 unknown reaction means that if total is 8, so we have remaining 3 unknown displacement. And these 3 unknown displacement is located at, okay, at B, 1 at B, and we have 2 at D. Okay, so we can start label. So we can label this as 1, 2, 3. 1, 2, 3, and then we have 4. Okay, we have 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, the arrow is given in the question. So what is missing is the coordinate, because in Truss we need to calculate Cx and Cy, so we have to put coordinate. Okay, so by looking at this diagram, so we can choose A as origin. So this is 0, 0, A as origin. So from this origin, we can put the remaining. Okay, so we have 3, we have, here is 4, 4, 5. So C is 4, 5. And then we have at D we have 1 and 3. 1 and 3. Okay, 1 and 3. And at A, not at A, at B, so we have 0 and 5. We have 0 and 5. Okay, so coordinate, we must have coordinate in order to calculate CS and CY. Or if we don't put coordinate, we have to calculate using we have to identify the delta X and delta Y. Okay, we have to calculate using not delta, theta, sine theta or cos theta. Okay, but this is the easiest way. So make sure before we start analysis, so we have to make sure in the diagram there are node number, element number, but the most important, the 3 important things that we need to put into the diagram is the arrow, the degree of freedom label, and coordinate. Okay, so label, element label we can put. Okay, we can put, because it is not given, so we can put like, okay, this is 1, this is 1, this is 2, okay, this is 3, this is 4, this is 5. So doesn't matter. You can put, okay, in any, okay, any one you want. You can also put 5 as 1, 4 as 2, doesn't matter. Okay, it is just the matter of position. It is position only. Position only. Okay, so we have settled A. Okay, now establish the force displacement equation. Okay, as I mentioned, we need to use the stiffness equation. Stiffness equation, it is Q equal to KD plus Q naught. Okay, Q is equal to KD plus Q naught. There are 5. 1, 2, 3, 4. Not 5, 4. Okay, it is 8 degree of freedom, representing 6 value of forces. And then we have K, it is 8 by 8. Okay, it is 8 by 8. And then we have 8 displacement from 1 to 8. And we need to plus with Q naught. Okay, we have to plus with Q naught. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 position. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so okay, the boundary is at 3, at position 3. No, after 3, the boundary. This is the boundary. Okay, the boundary is here, 3. Okay, the boundary is 3. Okay, differentiate between unconstrained and constrained system. Okay, five unknown reaction means that there are 5 zero displacement at position 4 until 8. So we have 0, 5, 4, 5, 6, 7, 8. And then we have D1, D2, D3. Okay. And for Q, we have 5, we have 3, this is the 3 unknown displacement, and we have 5 unknown reactions. Start from Q4. So this is Q4, Q5, Q6, Q7, Q8. So all these are the reaction at the support. There are 5 unknown reaction. Okay, so Q1, Q2, and Q3, we need to put with value. It cannot be unknown. It must be value. If the value is given, we use that value. If the value is not given, we put as 0. So 1, 2. So there is only, okay, at position 1 and at position 3. Position 1 and position, no, not position 1. Position 1 is 0. There is no, this one. Okay, there is no horizontal force at position 1. Okay, so the first value is 0. The second value is negative 30. Negative 30. Okay, because it is opposite. Not because it is downward, but this is actually because it opposite with sign convention, opposite with 2. So it is negative 30. Negative 30. So this is negative 30. Negative 30. And we have 25, which is occur in the same direction with DOF number 3. It is positive 25. Okay. Okay, I don't plan to show to you how to establish K. Okay, because I have explained it several times in my previous video. So K is structure stiffness metric. We combine all element, K from all element. So K for element we get from the formula given in appendix. Okay, given in appendix. And don't forget to label the element stiffness matrices correctly, so that we can get the right value of structure stiffness matrix. Okay, so I want to focus to this. Okay, this is what we call as Q naught in truss. Okay, Q naught in truss occur whenever the question, okay, get the effect from temperature changes or fabrication error, either one or combination. We must consider. Okay, in order to get equivalent nodal forces, Q knot. Okay, it is called as equivalent nodal forces. Equivalent nodal forces come from element. Okay, come from element. Means that we need to consider okay, one by one element. And by looking at the question, only member BD get affected. Only member BD get affected. So where is member BD? Okay, member BD is A, C, okay, BD. This only. Okay. Okay. Member BD. Member BD. So looking at the label for degree of freedom, and by looking at the arrow is in this direction. Okay, so the label is 3412. 3412 means that we will have Q. So it is element number 3. We label as element number 3. We label as element number 3. So we will get Q3 naught. Okay, the label for this. Okay, the label for this start from near 34. Okay, start from near 34 and 1, 2. Okay, 3, 4, 1, 2. So what is the formula? What is the formula? So looking to the formula. Okay, the formula is, it is delta L over L. It is delta L over L times with CXCY. Okay, CXCY, this labels is 3412. Okay, remember that this is Q. The unit must be in kilo. This is Q, so it means that we need to put, okay, additional AE in the formula. Additional AE in the formula. It must be AE. AE delta L over L. Okay, let's check. Okay, Q is force. Force is in unit kilonewton. Kilonewton. Okay, delta L in unit meter. Okay, delta L in unit meter. L in unit meter. So this L will be cancelled. AE is in unit kilonewton. Okay, and in the matrix, we need to use back CXCY, CXCY negative CX negative CY. Okay, so having this, we will get, okay, the value of Q3 naught in unit kilonewton. In unit kilonewton, so we have 4 values. So it is 3, 4, 1, 2. Okay, all these value, okay, after we substitute into this, so it is 0.00 negative, longer or shorter? Longer. It is longer. Okay, positive. This, okay, positive 0.005 divide by length. Okay, divide by length and then times with AE, or okay, times with AE times with CXCY, negative CX, negative CY. So let's say, okay, we have calculated the value and we get like this. Okay, let's say we get the value like this. This is, okay, 30, 40. Let's say negative 30, negative 40. So let's see. Okay, so I don't calculate this. Okay, this is assumption only. Okay, just fill in the value into the formula. You can check back the formula in the textbook. Calculate CXCY. You need to use this CXCY that you use in K3. Okay, in K3. So let's say this is the value. So we have to put into the stiffness equation. Stiffness equation. So all this value from the position. Okay, the label outside is actually the position. Okay, in the stiffness equation in Q naught. Okay, in this Q naught. So we put directly in this. We have negative, negative 30, negative 40, 30, 40. So the rest are all 0. Then only we can solve this displacement. Okay, this displacement, unknown displacement, after we include Q naught, which we get from a fabrication error. Okay, so we solve using calculator. It is actually 3 simultaneous equation. So we get this equation. D1, it is D1, D2, D3 equal to, it is, let's say it is 0 minus, bring to the other side, positive 30, negative 30, plus 40, 10, 25, minus 30, negative 5. Okay, this is not the answer. This is example only. So we substitute into calculator. Okay, and then just give the answer. Actually, you don't need to rewrite this back in 3 simultaneous equation, do it manually. You don't have to do that. Okay, what you need to do is you need to okay, key in all the values in the calculator and then straight away give the answer. All displacement, since this is truss, so all displacement will be in unit meter. And after that, only you can solve for, okay, you can solve for member force. So this is member force. Of course, you can also calculate reaction at pin support at A and C, as well as roller support at B. Okay, so this is how we analyze truss analysis. Okay, truss analysis using stiffness matrix method. Remember that in question C, member force, we need to use the formula. Okay, that is the formula that you need to refer. And actually, I have also made the one video explaining about that formula and the full solution until the end. Okay, you can watch that video as well. So I believe that I have covered all about, okay, important things that student need to know as preparation. Okay, not only for test, because this topic you need to use back under finite element method in next semester. Okay, so please refer to the formula for calculating member force, and you can also calculate the reaction at the support if needed, or if you want to do exercise to how to multiply using matrix. Okay, so I think that's all for this video. Inshallah, we will meet again in the next video. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.